Okay, so today we're going to be graphing system of equations. We are going to determine the number of solutions a system of linear equations has, and we're going to solve a system of linear equations by graphing. So let's take a look at this little example here. It says the cost to begin production on a band CD is $1,500. Each CD costs $4 to produce and will sell for $10. The band wants to know how many CDs they will have to sell to earn a profit. So, graphing a system can show when a company makes a profit. The cost of producing the CD can be modeled by the equation y equals 4x plus 1,500. So that's 4 times a CD, so $4 a CD plus the initial cost of $1,500, where y represents the cost of production and x is the number of CDs produced. Okay, so that would be this line right here. And then you can see there's another line, y equals 10x. Well, they sell each CD for $10. So y equals 10 times, or $10 times the number of CDs. So you can see this line here, where the lines cross, that's where you're going to start seeing a profit. So the income from CDs sold can be modeled by the equation y equals 10x, where y represents the total income of selling the CDs and x is the number of CDs sold. If we graph these equations, we can see at which point the band begins making a profit. The point where the two graphs intersect is where the band breaks even. This happens when the band sells 250 CDs. If the band sells more than 250 CDs, they will make a profit. So again, right here where they cross, that's the break-even point. So after that, all of this part would be profit. So they know they have to sell 250 CDs before they start making a profit. All right. Two equations, y equals 4x plus 1,500 and y equals 10x, form what's known as a system of equations. So a system of equations. The ordered pair that is a solution of both equations is the solution of the system. A system of two linear equations can have one solution. It can have an infinite number of solutions, or it could have no solution. If a system has at least one solution, it is said to be consistent. The graphs intersect at one point or are the same line. If a consistent system has exactly one solution, it is said to be independent. If it has an infinite number of solutions, it is dependent. This means that there are unlimited solutions that satisfy both equations. If a system has no solution, it is said to be inconsistent. The graphs are parallel. Okay? All right. I put this in here just to kind of show you the difference. So if it has exactly one number of solutions, it's consistent and independent, and it looks something like this. They cross at one spot. If it has an infinite number of solutions, it's consistent and dependent, and it'll be represented basically as one line. It's two lines over each other, okay? And if there's no solution, it would be inconsistent, and it would be a set of parallel lines. All right. So this one says, use the graph at the right to determine which system, or to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So first we're looking at y equals negative 2x plus 3. So we look for that. Y equals negative 2x plus 3. That's this line right here. And we have y equals x minus 5. That's this line right here. So we take a look at those two lines and we see, does it have one solution, infinite many, or no solutions? Well, they cross right here. So therefore it has one solution. So the system is consistent and independent. Okay? Next, let's change the color here. Next, they want us to look at y equals negative 2x minus 5, that's this line, and negative 2x plus 3. Again, that's this line. Well, when I look at those two lines, I can see that they are parallel lines. Being parallel lines, there's no solution to the system, and so the system is inconsistent. Okay? So let's take a look at these and see what we do. It says, use the graph of the right to identify whether each system is consistent or inconsistent, and if it is independent or dependent. So go ahead and try those and then come back and see how you did. Okay, let's see how you did. So number one, you should have had consistent and independent. Number two, you should have had consistent and dependent. Number three was inconsistent. And number four was consistent and independent. So again, you just look for where the lines crossed. Again, if you looked at number one, you would have this line and you would have this line. Well, you see they cross right here. So it's consistent because there's one solution, and it's independent because it's one solution. And that's, again, how you would do it, okay? Number two is consistent and dependent because it happens to be the same line. So you would have this one and so it's this line right here and this line right here. So it's the same line, okay? And so it's consistent and dependent. All right. Number 7. The method of solving system of equations is to graph the equations carefully on the same coordinate grid and find their point of intersection. This point is the solution of the system. So we are to graph each system and determine the number of solutions that it has. If it has one solution, name it. So we have y equals 3x plus 10, and we have y equals x minus 2. So we would need to graph both of those. Well, the y minus 2, we could put 0 in for x, and y would be negative 2. So that would be down here. We know the slope, because remember it's y equals mx plus b. M is the slope, and b is the y-intercept, or where it crosses the y-axis. So if my slope is 1, that would be up 1 over 1, so I would have a point. Then I could draw my line, okay? Then I have, for y is negative 3x plus 10, if I put 0 in for x, it crosses y at 10, so way up here somewhere, okay? So I don't necessarily want to do that. So what I can do is I can just pick really any point for x and y, and I can solve, or I could solve for where it crosses the x-axis. I could check that. Well, to do that, I would just simply put 0 in for y, and I would have 0 equals negative 3x plus 10. Subtract 10 from both sides. I get negative 10 equals negative 3x. Divide by negative 3, and I get x equals, let's see, 3.3 repeating. So just past 3, 1, 2, 3, which is about right here. And then the slope is negative 3. So I could go down 1, 2, 3, over to the right 1, and that would put it right here. So down 3 to the right, and draw my line. And I would notice that there is one place where they cross, okay? Now I would want to know, what is that solution? Where does it cross at, okay? So I could visually take a look at what it appears to be, and I could plug that into both of those equations and make sure they work. Well, it looks to me like they cross at 3, 1. So you'd put 3 in for the x, 1 in for the y, and solve. And you do that in both equations. If they both solve out, then that is your solution. Okay? 3, 1. Let's look at another one. We have 2x minus y equals negative 1, and 4x minus 2y equals 6. So first thing I would want to do on these is change it to where it's y equals mx plus b. So 2x minus y equals negative 1. I can subtract 2x from both sides, and I get negative y equals negative 2x minus 1. Then I would divide everything by negative 1, and I get y equals 2x plus 1. Okay? Then for the other one, I would have 4x minus 2y equals 6. Subtract 4x from both sides. I get negative 2y equals negative 4x plus 6. Divide everything by negative 2, and I get y equals 2x minus 3. Okay? Well, then I could graph those. Oops, there's a 2 there. I could graph those. 2x plus 1 is going to be this line right here, because I know it crosses the y-axis at 1, and it has a slope of 2, up 2 over 1. Then y equals 2x minus 3. I know it's going to cross the y-axis at negative 3, and it has a slope of 2x, up 2 over 1. Graph. Now, it's parallel lines, so the system is inconsistent. Okay? If it didn't tell me to graph it, if it just gave me the system of equations, 2x minus y equals negative 1 and 4x minus 2y equals 6, and said, what type is it? Is it consistent, inconsistent? What is it? Well, I know once I get it to y equals mx plus b, when they both have the exact same slope, that's going to be parallel lines. So I know right away it's going to be inconsistent. Okay? All right. So take a second, try this one, and see what you get. All right, so let's see how you did. So 2x plus y equals 6. I can convert that by subtracting 2x from both sides and get y equals negative 2x plus 6. So I know the y-intercept is at 6, so I put that point, and then my slope is negative 2, so down 2 over 1, and draw my line. And then 2x minus y equals negative 2. I would subtract 2x from both sides. Then I would have to divide everything by negative 1 to give me y equals 2x plus 2. The y-intercept is going to cross the y-axis at 2, and then it's going to go up 2 over 1 for its slope, and then draw the line. Then where they cross would be the solution. So it would have one solution, and it would be at 1, 4. Okay? And again, I could check that by plugging in the numbers 1, 4 into each one of those equations, and they will equal out. All right, try this one too. Okay, let's see how you did. So 2x minus y equals 1. I'd subtract 2x from both sides, and then I would divide everything by negative 1 to get y equals 2x minus 1. So you know it's going to cross the y-axis at negative 1, and then it has a positive 2 slope. So up 2 to the right 1, draw my line. Now y equals negative 3 is everywhere y is negative 3, so it is a horizontal line. So then I look at where they cross. Now if I would have drawn an actual straight line for the 2x minus y equals 1 line, it would have crossed right at negative 1, negative 3. But I can check that. And so I wanted to make sure, well, I know that y equals negative 3. So all I have to do is plug negative 3 in for y and then solve for x. And when I did, I get x is negative 1. So it's one solution at negative 1, negative 3. Okay? Any questions? Let me know.